Before we talk about calculating greenhouse gases, I want to talk about where greenhouse gases come from. So, did you know that the majority of global emissions, so nearly 75% of global emissions, are attributed to energy use? And think about it, from air conditioning and heating to driving around in our cars or trucks, to flying to a vacation spot, to manufacturing, buying, and disposing of goods. We humans use a lot of energy for our modern day lifestyles. In fact, the greatest user of energy is industry. So I'm glad you all are here with me today. The second users are buildings and transportation. Second and third users are buildings and transportation. So when we say energy related emissions, typically this is referring to combustion of fossil fuels. Then there's other sources of emissions, for example, from agriculture or harvesting, cutting down forests, or just restoration of trees, land use, waste, and also other greenhouse gases arising in the industrial processes. So what are the greenhouse gases? We're going to go back to 5th grade here. The main greenhouse gases are carbon dioxide, methane, and nitrous oxide. So those are CO2, CH4, and N2O. These are all naturally occurring greenhouse gases. Then we have our fluorinated gases. These are manufactured or synthetic gases, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. These are usually found in refrigerant systems or electrical equipment. So these are the six categories of gases that you're typically going to see in a greenhouse gas footprint. When you see a greenhouse gas footprint reported, it's usually going to be reported in these 3 scopes. So the Greenhouse Gas Protocol is the global leading institution on greenhouse gas accounting methodologies. They were the ones that developed this categorization. So scope 1 refers to your direct on-site emissions. So think about your home. If you have a natural gas stove or a gasoline-powered lawnmower, those are considered direct within property boundaries emissions. Scope 2 emissions are called indirect emissions, and this is from imported energy sources such as electric, or in Europe or other places, not so much in the US, they have district heating and cooling systems, and that's considered an imported energy source. Then we have scope 3. So scope 3 is basically everything else. Think about all the stuff you've ever bought and thrown away in your life. All of those materials were manufactured somewhere in a facility, transported to your door. You used them, and then in most cases, they're probably thrown away, although obviously we all have furniture and things in our house, but disposal of goods is also considered in what is this scope 3 value chain emissions. And it's not just goods, but it accounts for services and travel as well. So what do you need to start calculating your greenhouse gas footprint for your business? Well, you're going to start off with your scope 1 and 2. That's always a great place to start. And if your business gets billed for utilities, you can start this process today. So, what info do you need? The first thing to do is to set up that organizational scope. So what facilities, what kind of transportation is our business using? How much electric are we importing? Then you're going to need that activity data, and that's going to come directly from your utility bills. So the type and quantity of energy, for example, natural gas or electricity, that's considered your activity data. Then you're going to need emissions factors for those energy sources, as well as global warming potentials for those energy sources. And I'm going to cover those here in just a minute. So what is an emissions factor? An emissions factor, remember, the vast majority of your scope 1 and 2 emissions are coming from your energy sources. Not all energy sources are created equal. So for example, coal is considered one of the dirtiest forms of fuel because when burned, its smoke contains unburned or half-burned particles of carbon, sulfur oxide, and other VOCs, or volatile organic compounds. The burning coal creates carbon monoxide as well as smog. Natural gas, on the other hand, burns much cleaner, and so that is reflected in what we call the emissions factor. So it's the quantity of combusted molecules of carbon, methane, and nitrous oxide. So just how much of each molecule and energy these sources emit when we combust them, that is what is called the emissions factor. Energy is measured in British thermal units, which is the amount of energy it takes to heat 1 pound of water by 1 degree Fahrenheit. The molecules in, a chunk of wood or a chunk of coal, what have you, are measured in weight. And the emission factor is the ratio of molecules to the energy provided by any particular energy source. So this image is an excerpt from the EPA emissions factors table. If you want to jump in the chat or jump off of mute, if somebody could figure out what fuel type has the lowest methane factor on this list, you get a gold star for the day. Now, some of your factors depend on your geographic region. So if you say my business imported 1,000 kilowatt hours of electric this month, that's how much electric we used. The electric emissions factor goes by a regional grid because you're burning often a combination of fuels to generate that electricity. So you go to your emissions factor hub, and that's where you can find all of this. No guesses or nothing on the methane. Oh, we have one person in the chat. Wood. Nailed it, Michael. Yes, so wood has the lowest methane factor. Anyway, just a fun fact. All right, so then, as I mentioned, the global warming potential. The global warming potential is each molecule's capacity for trapping heat. And as these molecules are burned, they become gaseous, go to the atmosphere, they're trapping heat in the atmosphere, but eventually they do degrade. These molecules don't last forever. So anywhere between 12 and 50,000 years, these molecules are going to be in the atmosphere after they are released. And the global warming potential takes into account the degradation of the molecule as well. So carbon dioxide here is our base of 1, global warming potential of 1. And then methane, for example, is 21 times the heat trapping capacity of carbon dioxide. Now, the thing with these synthetic gases, these fluorinated gases, the fluoride molecule adds a lot of stability. So these gases last a lot longer in our atmosphere, and they're also, they're used in refrigerants. So they have really good heat trapping capabilities. And so their global warming potentials are thousands times that of the natural greenhouse gases. So they're particularly potent. So how does the calculation actually work? So the math behind it. Some of these screenshots are from a client I actually worked with. And so here you can see they input their fossil gas or natural gas use for that cycle. So they used roughly 5,300 megawatt hours of gas as per their utility bill. And that is equivalent to 971 tons of greenhouse gases or carbon dioxide equivalent. So the math behind that is you're basically taking the quantity of fuel multiplying it by the emissions factor for each molecule and the global warming potential for each molecule. So you're basically creating ratios, and then you sum that all together for carbon dioxide, methane, and nitrous oxide, and that will give you your tons carbon dioxide equivalent. It's actually a pet peeve of mine when it's called a carbon footprint, because carbon isn't the only greenhouse gas that's out there. So I like to say greenhouse gas footprint. But yes, it is a weight-based unit. And also, energy, it gets billed in all different kinds of units. You may have BTUs, you may have megawatts, you may have kilowatts. And so you have to make sure all of your energy sources are converted into, depending on your emission, you can do emissions factor based on weight or by megawatt. So just you have to watch your units and match that to the correct emissions factor. Here's an example of, again, a real life business. This is their scope 1 and 2 footprint, going back from 2022 back to 2015. So in 2015, this organization's total scope 1 and 2 emissions was just over 34,000 tons of CO2 equivalent. For scale, 1 ton of CO2 equivalent is roughly 1,000 pounds of coal that has been burned, or 15% the annual energy use of the average US home. So do the math, multiply that by 34,000, and you can start to see why industry, those numbers start adding up very quickly in industry and all these companies that we work for. My personal home energy use, I use about 4,000 or 4 megawatt hours of energy per year, which is less than 1 ton of carbon dioxide equivalent. So in 2015 to 2016, there was a major drop in total emissions. Again, if you want to drop in the chat why you think that happened, but you can see the orange is imported non-renewable electric. And the blue, the dark blue, is natural gas. So this facility was using, roughly 65% electric for its energy and 30 supplied by gas. And then of course we have some diesel generation reflected here, backup generation, and then also there is some refrigerants in this chart as well. So what happened between 2015 and 2016 is this facility started purchasing 100% renewable electric through a PPA. And so when you purchase renewable energy, those emissions are 0. And so that's why you see that grand fell swoop of nearly 24,000 tons of carbon dioxide just dropping off the map, is because they started purchasing renewable energy from that year on. Now, a note on business processes. As I said, if you get billed for utilities, you can start this process today. So your business, at some interval, whether it be monthly or quarterly, you're getting an electric or a gas or what have you, a bill for these utilities, goods, and services. In some cases, depending on the maturity of your facility, you may have access to electric or other meters, or maybe you have software that monitors this use more real time. And so those are all your kind of base starting points for your data. That data gets transcribed from the utility bills into whatever system you're using to track. It could be a financial system. It could be a software. It could be Excel. And I worked for a global company, 80,000 people, and we were tracking this in Excel. Now, there is more softwares out there now that today more than ever. So I would definitely suggest going the software route to calculate your greenhouse gas footprint, but it can be done in Excel. And also the Greenhouse Gas Protocol has a great free tool that you can use just to get started. Then, as I said before, your scope 1 and 2 footprint are basically your facilities. So depending on how many facilities your company owns, you're going to repeat that process for each facility and then roll that up into a geographic region or a business unit like operations versus commercial. And then all of those facilities and transportation methods within your company is going to get added up, and that will create your global footprint. So the genesis of your global footprint is your individual sites. Then I would hope if you're going through all the trouble of doing these calculations, you would actually share it either internally or externally. So your company may develop an annual sustainability report, or it may have other disclosure frameworks that it needs to report to, or customers, especially if you have corporate clients, they may start asking more and more from their suppliers for these kinds of metrics. So that is the business process. Now, here's another example. This is a full scope 1, 2, and 3 example from Crocs. And this is from their sustainability report published online. If you have a favorite product, I encourage you to Google their annual sustainability report, A, to see if they have one, and B, just read it and kind of see how it feels to you. But their scope 1 and 2 footprint was 15,000, call it 400 tons of CO2 equivalent. And this was in 2022. So 15,000 tons CO2 equivalent is roughly 3,500 cars driven around for 1 year, almost 17 million pounds of coal being burned, or 4 wind turbines running for a year. Now, their scope 3 footprint is 762,000 tons of carbon dioxide equivalent. So that's actually over 97% of their total. Excuse me. And that is not uncommon because your scope 3 footprint is everything that's outside of your facility. It's not uncommon to see scope 3 footprints that are a number of times higher than your scope 1 and 2. I haven't seen a scope 3 footprint that was less than 75% of the total. So your scope 3 is going to be 80-90% of your total footprint there. So this leads us into scope 3 emissions. So as I said, scope 3 is basically everything else. So the goods and services that your company purchases, how it's transporting its products, business travel, waste and waste disposal, if there's leased assets or franchises, this is all considered in scope 3. So that being said, what kind of information do you need to start calculating your scope 3 footprint? Well, again, you need your activity data and your emissions factor. So that activity data is going to look a little bit different than your scope 1 and 2. Most of the time, at least right now, your scope 3 activity data is going to be based on spend. This is like me saying to the grocery store, hey, what's the product life cycle emissions for this box of cereal, right? Unless they've done that work, which many companies haven't, they're going to say, I don't know. And so you say, okay, I spent $4 on this box of cereal, and you're going to use industry averages, or, that's where the emissions factor comes in. You're going to, depending on what you're buying with that spend, you're going to apply the appropriate emissions factor there. Sometimes your product may have life cycle emissions available from a company, and so you're going to need the quantity of materials. Again, since scope 3 is such a broad umbrella, there may be other factors that you're going to base your calculations off of, for example, weight, distance traveled, or square footage if it's a facility of one of your suppliers. It depends on exactly what you want to calculate, and you're going to work backwards from there for your data source. As for the emissions factor, it's either going to be a primary or secondary emissions factor. So the primary is a direct, yes, here's how much carbon emissions our facility emitted, or here's the life cycle emissions of product X. That's a primary direct emissions factor. And then a secondary emissions factor would be a spend-based emissions factor or an industry average. And there's various catalogs of emissions factors out there in the greenhouse gas protocol. Here's an example of a decision tree that you might use. This example is for business travel. So first you're going to want to ask, does business travel significantly contribute to our scope 3 emissions? If you have 5 employees and they're all commuting locally to come to your office, that's not going to be a significant impact on your total emissions. Now, if you have a company of 10 and 5 of those folks are traveling globally as sales reps or business executives, that would be more significant. Then based on, you're going to go through the decision tree, and here you could use a fuel-based method. It could be a distance-based method, or it could be spend. And again, this requires your business interfacing with suppliers, asking, what kind of data do you have that you'd be willing to share with us? In most cases, in this day and age, we're still mostly in the spend-based, methods here. But as these requirements and requests trickle down to smaller businesses, it will get more into these more specific primary data sources. Here's an example of product-based emissions. So company A is a construction company. They're buying cement, plaster, paint, etc. They asked their suppliers 3 years ago to start calculating the carbon footprints of their products. And so it took 2 years for the suppliers to baseline and then actually perform those calculations. But now company A has the supplier specific emissions factor. And again, this is a weight per carbon dioxide equivalent unit. So in here it's kilograms rather than tons per kilogram of purchased good. So they purchased 200,000 kilograms of cement, and at 0.15 kilograms carbon dioxide equivalent, you would do that for each good, add that up, and that's an example of using product-based emissions factors. So we're wrapping up here, but basically, you can't improve what you don't measure. The climate crisis is real. Business as usual is no longer an option. Legislation is starting to require very large businesses to start reporting and disclose their greenhouse gas footprints. And along with that, those requirements will trickle down to smaller businesses. And lastly, it's just the right thing to do. Corporates with a conscience know that calculating their greenhouse gas footprint is starting to become a competitive advantage, not just when you calculate it and disclose it, but actively work to reduce those total greenhouse gas emissions. So you can't just calculate it. You actually have to do stuff to reduce it after that. All right, so this was the majority of the presentation. I hope it sheds some light on how a commercial greenhouse gas footprint is calculated. Please do stay in touch with myself, SustainabilitE Solutions. I do one of these webinars every month. I can virtually or in person give a Sustainability 101 training. I do sustainability baselining. I have some products for digital download to help your businesses start on this journey. I can be found on LinkedIn, Instagram, and Facebook. So thank you very much.